Hi Pre-Calculus. Welcome to our third video in working with trigonometric identities. We're going to work on simplifying them as well as verifying them. So let's just make a list of some things to try when you're simplifying trig expressions or when you're verifying. Okay, one of the first things you should think about is using the identities, okay, especially the Pythagorean identities. So you can use Pythagorean identities, but that's only if you see things that are squared, okay? So look for things that are squared, and you might be able to use some of these identities. So the first one that you have to have memorized is sine squared of x plus cosine squared of x, and that makes a 1. Okay, so that's the first one. And of course you can rearrange these. So if you happen to see 1 minus sine squared of x, what would we replace that with? If the sine squared of x was on the right-hand side, that would be equal to cosine squared of x. They all have to have the same angle. Don't forget to put the angle, okay? And you have to be squared. The second Pythagorean identity is related to this first one. So if these were all divided by sine squared of x divided by sine squared would be 1. Divide this one by sine squared. Then you get cotangent squared of x. Divide him by sine squared and you get cosecant squared of x. So that's the second identity. And of course this could be rearranged. If you happen to see cotangent squared of x minus cosecant squared of x, what would that be equal to? If cosecant squared was on the left-hand side, then the 1 would go over there. That would be replaced with a negative 1. And then the third Pythagorean identity is if you take this first one, divide them all by cosine squared. Sine squared divided by cosine squared is tangent squared. Divided by cosine squared, that's a 1. And that would be secant squared of x. What if you happen to see 1 minus secant squared of x? What would we replace that with? Negative tangent squared of x. That would be the first thing to do, to think of if you see squares. Another technique that we talked about a little bit was factoring. Okay, so take a look and see if you could factor. Can you factor anything out? Let's see. You can make common denominators. Okay, making common denominators is a good technique. Denominators, but again, only if you see fractions. If you don't have fractions, that's not going to be a good technique. Something that we started this chapter off with was making all of them, make all the terms into sines and cosines. Okay, then at least they'll all match. Okay, so you can change all the terms into something else, and then you might be able to use some of the reciprocal identities, or some of the quotient identities. Okay, but those aren't squared. Let's see, something else we talked about was multiply by conjugates. Multiplying by conjugates is a great technique. Conjugates, okay. The reason is when you multiply by conjugates, they make a difference of squares. And when you have the difference of squares, things are then squared, and then you might be able to use some of your Pythagorean identities. And the most important thing to try, the most important technique, no matter what kind of problem you have, okay, I'm going to give this one 3 stars. Don't be a quitter. Do not be a quitter. You are not going to be able to get this done if you don't keep trying. It's okay to try things, and if it's not working, you can just go back and start a different technique. Okay? Don't be afraid to try something else. All right, number 1, Okay, they want us to simplify by factor. All types of factoring. So let's take a look at the numerator here. I see a difference of squares. So I'm going to factor the numerator, okay, sine squared minus 1, into two quantities, difference of squares. That's going to be sine of v minus 1 times the sine of v plus 1. Okay, so the type of factoring that we did here was difference of squares. Is there anything we could do with factoring in the bottom? Okay. Well, it's not squared, okay, but maybe we could factor out a GCF, the greatest common factor. They both have a cosine of v, so I'm going to factor out a cosine of v. The first term there would be left with sine of v, but then you need something else, so minus 1. Is that true if we distribute it back in? Okay, that's looking good. Now, what are we going to do? Are we allowed to cancel anything? This is an entire quantity, and this is an entire quantity. You are allowed to cancel them if they are the same. And so in the numerator, we have sine of v plus 1 divided by cosine of v. We can't really cancel anything here. This is two terms on top and one term on the bottom. So we have three terms and we have a fraction. So I guess what's more simple, a fraction or not a fraction? Let's try to make this not be a fraction. Okay, we could do the technique where I heart math. So who gets a denominator of cosine? Does sine of v get a denominator? Of course he does. Okay. Plus, does 1 get a denominator? I'm going to give them each their own cosine of v. See how these are common denominators, and if I added them together, I would add the numerators? Okay, but how did this help? Because I still have fractions. Okay, and remember, not fractions would be more simple. So how can I write this as a final answer that doesn't have fractions? So the first term, sine over cosine, could be a tangent of v. That's not a fraction. Is there any way to write this as not a fraction? 1 over cosine, I could write that as a secant of v. Can I add those together? No. Ooh, what about one of the identities? Is there any way to use an identity, like a Pythagorean identity? No, because they're not squared. They're not squared. So we are done. Okay. Simplifying is actually a little trickier because you have to keep simplifying until you think you're done. The best way to do that is to get lots of experience. Okay, so please make sure you're doing your assignments. Number 2, how are we going to work with two fractions that are being subtracted? Two fractions that are being subtracted, we're going to have to make common denominators. Make some common denominators. It's the only way to deal with fractions. Okay, so equal sign. My first fraction right here, I'm just going to write him down. But whenever I see plus and minus signs, I'm going to put parentheses around that quantity. Okay, the second one is sine of x over cosine of x. Okay, there's no plus signs or minus signs in that fraction. I need the denominators to be common. So this first fraction needs a cosine in his denominator. So if I multiply the bottom by cosine of x, I have to multiply the top by cosine of x. This second fraction here is going to need to get this quantity. So I have to put in parentheses, 1 minus sine of x on the bottom, 1 minus sine of x on the top. Please make sure you write it 2 times. So their denominators are now common. I'm going to go ahead and write those denominators together. The common denominators, they each have a cosine of x and the quantity 1 minus sine. Now, what about the numerators? I didn't distribute the denominator because I might be able to cancel something later. So I'll distribute that if I need to. But the numerator, we're going to have to distribute so I can see all of the terms. I got to put them together. So the first term here is cosine squared of x. Notice the squared power goes there. Here I'm going to have to distribute. Okay, but be careful, that's a minus. So we're going to distribute a negative sine of x. So minus sine of x. But then that's going to be plus sine squared of x. Okay. Do you think we're done? No, I'm sure there's more things we can do. Okay, so I have to clean up this numerator a little bit. I see cosine squared right here. That's a squared. And then I see plus sine squared. Is there anything I can do replacing? Because those are squared, I'm thinking of the identities. Sine squared plus cosine squared, that can be replaced with a 1. Okay, let's write the rest of the problem down. Remember, you're only allowed to do one step per line. So I've replaced those two with that one. That's more simple. Anytime you have plus and minus signs, put parentheses around that quantity. You are not allowed to cancel just one of his things. He's a quantity. You cancel all of him or you cancel none of him. Okay? I hope at this point you're getting a little excited. Like in your stomach, can you tell if this is the right way? 1 minus sign divided by 1 minus sign, that quantity cancels. And we are left with 1 over cosine of x. Okay, how many people already wrote the final answer? Yeah, you could write this as secant of x. That is definitely done. Number three. I see some more fractions. Okay, we're gonna have to make some common denominators. I'm gonna write this problem spread out just a little bit more so I can fit my common denominator work in there and everything's nice and organized. Sometimes the worst thing to do is to squeeze things in and then you lose things. That's just gonna make a mistake. Okay, wherever you have quantities with plus and minus signs, put parentheses around that quantity. You certainly could put them around sign. That's not going to hurt. Okay, but it's the ones with plus and minuses we need to make sure we think of as a group. Okay, so the common denominator here. So this first fraction needs to get a sine of theta over sine of theta. The second fraction needs to get this common denominator. So 1 plus cosine of theta, top and bottom. Okay, so let's see, what does that make? Do you think I should distribute in the denominator? No, let's leave them separate because you never know if we can cancel them out. So we have a sine of theta and a 1 plus cosine in the denominator. Now how about the numerator? Do you think I should distribute these? Do you think sine times sine should be written as sine squared? Of course, sine squared of x. Over here, we're going to have to make sure we factor. It's got a plus sign. Distribute these factors. So we've got 1 times 1 out firsts, and then the outers and the inners. That's going to be 2 cosine of theta, and then the lasts plus cosine squared of theta. Okay, let's see. There's a lot of squares here. So let's just go look at them for a second. We've got a sine squared and a cosine squared. So those are going to be replaced with a 1. We still have this 1 plus 2 cosine theta. The denominator is all here. Okay, now we have 1 plus 1, so that's going to make a 2. So in the numerator we have 2 plus 2 cosine theta. Can we do anything else? Can we add this 2 plus this 2? No, because that's a coefficient there. I'm trying to think about canceling. There's no squares. We can't use Pythagorean. There's no sines. There is some cosines here, except this says 1 plus cosine. And this is 2 plus 2 cosines. Can I cancel the cosine with the cosine? No, we can't. Remember, whenever you get stuck in pre-calc, the answer is usually factor. Okay, so what can I factor out? There's 2 terms here, and they both have a 2. I'm going to factor the 2 out. Factor the 2 out, and that would be 1 plus cosine of theta divided by the denominator. Okay, did that help at all? Did that help? Well, since these are exact quantities, we can cancel everything out. We have 2 over the sine of theta. Okay, in fact, I'm going to write this as 2. And then we have 1 over sine of theta. Okay, 1 over sine of theta can be written using the reciprocal identities as cosecant of theta. Look how small that got. Okay, let's keep going. Number 4. Okay, they tell us they want us to factor to simplify. So we do have to do some factoring. I'm going to show you a technique that sometimes they use, especially as you go higher in math. So when you get to calculus and things start getting complicated, you can replace them or just kind of look at them in terms of something else. So if factoring this is challenging, you can think of this as a's. So if I looked at sine squared and thought of that as a squared, and then there's a sine, so that would just be minus an a, minus 6. Can you get this thing factored? Does thinking of it in terms of a's make it easier for you? Okay, so this would be a minus 3 and a plus 2. Okay, but this problem wasn't a's. Okay, it was sines. If you are able to think in terms of sines right away, okay, then go for that. So we're doing factoring a quadratic by guess and check. MA table would be a lot of work, so at this point I hope you can just factor straight up. This is going to be sine of theta and then minus 3. Okay, because the a thing was a sine. The second quantity was a plus 2, but I'm going to write sine of theta plus 2. Now, I guess you could do the same trick in the bottom. If you can get this denominator factored without doing a's, go for it. If it's just a little complicated to kind of think of, you could think over here in the corner, 2 times a squared, then plus 3 times an a minus 2. So if that helps you factor, go ahead. So this is going to be 2a minus 1 and a plus 2. So down here that would be 2 sine of theta minus 1 sine of theta plus 2. Okay. Now it doesn't necessarily have to work out this way, but when I'm doing these problems, I'm thinking one of them is probably going to be an identical quantity. So just double check your factoring if nothing matches. Sometimes it doesn't, but usually there is a common quantity. We can cancel the entire thing out, and we're left with sine of theta minus 3 and 2 sine theta minus 1. Now these are quantities, so you can't cancel anything. I can't really write them as reciprocals at all. This is a quantity. I can multiply by conjugates, but since that's a 2, we're not going to get Pythagorean identities. So this one, we're just going to stop right here. Okay, so there's a trick to help you with the factoring if it's a little too complicated in your mind with looking at it like sines. Verify means to show to show or to prove it is true. Okay, so verify means show how this expression equals secant. Okay, please don't take a verify problem on a test and tell me, oh, it's not true. Okay, it is true. Your job is to show how you can establish the left side turning into the right hand side. Okay, verify. Now, something important that we have to make note of, okay? You can only work on one side. You can't mess up both sides. You can only work on one side. So pick the more complicated side. You pick the side that's more complicated. You simplify it and you turn it into the right-hand side. Okay, so I'm looking at the two sides. The left side is definitely more complicated. Okay, so here's how you start. Left-hand side equals. Left-hand side. Okay, so what side did I pick? I picked the left-hand side. I'm going to show how this left-hand side can turn into the right-hand side. And that's what I'm going to be proving here. Okay, so what you're going to do is have work, 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 and then at the end, I really hope that this is the answer. Okay, so this is the answer. Let's write down the left-hand side. So I'm going to have to somehow work with this. They're not squared, so we can't use Pythagorean identities. They're not fractions. I can't factor. So maybe I'll use the technique changing everything into sines and cosine. A cosecant of theta, that would be 1 over sine of theta. And a tangent. Tangent is sine over cosine of theta. So does that help us? Sure it does. Sure it does. We can cancel the sine with the sine. And now we're left with, in the numerator, 1 over cosine of theta. Okay, now remember, we know what the answer is. The answer is right here. I have to make secant. Are we making secant? We are. 1 divided by cosine makes secant of theta, which is the right-hand side. Okay, so we turned the left-hand side into the right-hand side. All right, so the answer is right there. You know what the answer is. You just have to show all the work. Okay, so verify or establish. Okay, establish means, it means show all the work, okay, to make the other side. Show all the work, okay? So please don't write a bunch of mess. Ooh, equals magic answer, okay? This is what I'm grading, all the steps here, not the answer. All right, so let's try another verify. Okay, so what side do you think we should work on? So there's no right or wrong answer here. No right or wrong answer. I'm going to start with the left-hand side here. Start with the left-hand side. So I'm going to write left-hand side. Left-hand side. We've got cosecant of u minus cotangent of u. Okay, now they're not squares, so maybe we should write them as fractions. Cosecant of u is 1 over sine of u. Cotangent is cosine of u over sine of u. Okay, and those are common denominators. So let's go ahead and write them with the common denominator and add the numerators together. Now, are we done? Let's go see. Did we make the right-hand side yet? Nope, that's not it. We have to keep going. We have to make that. Nothing squared. maybe what we'll have to do here, okay, is multiply by a conjugate. Multiply by a conjugate. So if we do 1 plus cosine of u in the numerator, we'll have to do that in the denominator. Okay, let's just take a break and look. If I give the denominator that quantity, is that a good idea based on what I'm trying to make? Yeah, that's looking pretty good. Look, that's in the denominator. Okay, but the numerator somehow has to turn into a sign. All right, let's keep going. The reason why you multiply by conjugates, okay, so we did some conjugates here. And the reason we do that is they multiply so nicely. They're going to make a difference of squares. Okay, difference of squares. Difference of squares. And then in the denominator, I'm just going to leave that factored like that. Okay, now remember, let's go see what we're trying to make. We're trying to make signs in the numerator. So we have to get rid of cosine squares. It is a square. Why don't we think about some Pythagorean identities? Let's see, maybe I'll go up here. So in the numerator, 1 minus cosine squared, how can I write that? That could be a sine squared of u. We still have our denominator. Okay, let's go look at what we're supposed to make. We're not supposed to have a sign in the denominator. And we're only supposed to have one sign in the numerator. Now, what do you think we need to do here? We're going to have to cancel. Okay, this is sine squared. So if I cancel one of his signs, he's left with 1, and I'll cancel one of his signs. And now in the numerator, we have a single sign, and in the denominator, we have that quantity, and look at that. It equals the right-hand side. I proved how the left-hand side can turn into the right-hand side. Is this a true identity? It is. Okay, we got our last one right here. Last one. We've got the left-hand side equaling the right-hand side. I'll start with the left-hand side. They both look equally complicated. Okay, so we'll start with left-hand side. 1 plus sine of theta divided by 1 minus sine of theta. Okay, what kind of technique can we use here? Maybe we should do some conjugates. 1 minus sine. So let's put parentheses so we don't mess that up. And I'm going to multiply top and bottom. Let's see. Which conjugate should I use? I'm going to use conjugate of the denominator. I want the denominator usually to be the one to get nice and simple. Okay, so in the numerator, we have 1 plus sine. I'm going to write that as quantity squared. The denominator, I'm going to go ahead and multiply up because that's going to make conjugates, right? 1 minus sine squared of theta. Okay, which is an identity. So let's see. The denominator, instead of that, can be written as cosine squared of theta. Okay, let's see. That's not what we have here. So I think we are going to have to multiply this numerator out. We're going to have to let's make all the terms. Okay, so that's going to be the quantity squared 2 times. So first, and then the outers, and then inners combined, and then the lasts, divided by cosine squared of theta. Now, who gets divided by cosine squared? Each of them. So we have 1 getting divided by cosine squared, and then 2 times sine gets divided by cosine squared, and sine squared over cosine squared. When you think of that, that makes me say tangent squared, right? This is tangent squared. Let's go take a look at the problem again. Oh no. We're supposed to be making cosecant plus 1 and cosecant minus 1. Well, this is a secant squared. This is a tangent squared. Do you feel like we are getting anywhere near this? Are we simplifying or are we complicating things? You know, I don't feel like this is the best approach. We were trying so hard here. I think it's time to abort. This is not the right way. I gotta try again. Okay, sometimes this happens. Sometimes you do something and it's just not the right approach. We gotta try again. Left hand side. Let's try something else. Okay? Sometimes that happens. Okay, so this is my left-hand side. Let's think a little harder how we can make this right-hand side. So what I did in making all these terms, that was not right. It's kind of already in the right form. So I need to make a big fraction bar, and it has a big fraction bar. So I don't want to mess that up too much. It's got a minus sign, and this has a minus sign. The top is supposed to get a plus sign. It already has a plus sign. Okay, so I don't want to mess it up too much. It's supposed to have 2 terms in the numerator. And it has 2 terms in the numerator. So it's not actually that bad in terms of the formatting, except the first term here is supposed to be a cosecant. And the second term, I'm supposed to make a 1. I gotta make a 1. How can I take a sine and turn it into a 1? I mean, if I divided him by sine of theta, that would turn him into a 1. Okay, but that's not fair. You can't just divide one thing by sine. If I did that, I would have to divide all the things by sine of theta. I would have to divide all the terms on the top and all the terms on the bottom. Hey, that would make a 1 right where I needed it. What's 1 divided by sine make? Hey guys, I think we figured it out. 1 divided by sine makes cosecant. We've got the plus sign. This makes a 1. Oh my gosh, that's all we had to do, was just divide them all by sine. That is the right-hand side. Look how fast that was. You know what we did here? We didn't give up. We were not a quitter. And we got the job done. Great job.